Welcome to our channel Crypto Network. We are here to start EIGRP Protocol Part 2. Enhanced Interior Gateway Routing Protocol EIGRP is very simple to configure. Under config mode, we have to type router EIGRP AS number. So AS is autonomous number and that can be from 1 to 65535. Now network address command shown here specify only the directly connected network or networks of the router. And after the initial and EIGRP configuration on all routers, we can use the show IP route command to view the routing table. And as I said earlier, the character D at the beginning of a line in routing table shows that it is a route discovered by EIGRP. Right, so EIGRP mainly uses 5 packet types in communication with its neighbors. One is hello. Hello to discover neighbors and are sent to the link local multicast group address 224.0.0.10. We have update packet, route change information that is only to affected routers to update with new routes, and that is multicast. To synchronize topology tables, the nature is unicast and the delivery is reliable. We have query packet, query when router has not feasible successor, it sends multicast to neighbors, and that is again reliable delivery. Reply packet. So unicast to a query. A router must reply to all queries, and that is always reliable. Acknowledgement to acknowledge updates, queries, and replies. It is unicast in nature. We have two more types. One is request that are used in root server applications. So root server is only aware of the destination that it can reach. That provides a more global view of a geographic area than a router. The seventh packet type is goodbye, that is used by a router to notify its neighbors when the router is gracefully shutting down. All right. So a root is active. We have a root states in EIGRP, active and passive. So a root inactive when it is undergoing recomputation, and considered passive when the root is not performing recomputation on that root. Meaning, when EIGRP loses a root and there is no feasible successor, the root will go from passive to active and the router starts sending queries to its neighbors. And if the router doesn't receive a reply in response to all the outstanding queries within 1 seconds, it will put the root in SIA, stuck in active state, and drop the neighbor adjacency. So summarization in EIGRP. EIGRP automatic summarization on the major network boundary, and that can be turned on or off. The auto summary feature can cause problems with discontiguous networks. To turn off automatic summarization, use the no auto summary router configuration command. EIGRP has added functionality to allow administrators to create one or more summary routes on any router within the network. Use the command IP summary address EIGRP autonomous number, then the address mask. That is here in an example IP summary address EIGRP, that is the autonomous system number 10, the network address, and the wildcard mask. You can use the subnet mask as well. So uh, manually creating a summary route at an arbitrary bit boundary. All right. So EIGRP passive interfaces. So passive interface command is used in all routing protocols to disable sending updates out from a specific interface. However, the command behavior varies from one protocol to another. In EIGRP, the passive interface command stops sending outgoing hello packets. Hence, the router cannot form any neighbor relationships via the passive interface. This behavior stops both outgoing and incoming routing updates. So command is simple. Under config mode, we have to type router EIGRP AS number, and under config router passive interface, the serial number or the interface name where we want to enable this passive interface. If we want to configure on all interfaces, we have to punch in passive interface default command. Okay, so EIGRP authentication. So by using the same pre-shared key on all routers, you can force EIGRP to authenticate every EIGRP message. That way you can ensure that your router accepts routing updates only from trusted sources. EIGRP uses the concept of keychains, and each keychain can have many keys, just like in real life. After you have created a keychain with the corresponding keys, you need to enable EIGRP authentication for a particular interface. And to configure a router to use EIGRP configuration, the following commands are used. Uh, Keychain, keychain name. We are creating a keychain name by the name EIGRP. Uh, and Key number. Key number identifies the key number. Here, key 1. Uh, Key string. Uh, in here, we are naming testing. So this name specifies the key string for the key. Next, we need to enable EIGRP authentication on interface. So IP authentication mode EIGRP AS MD5 enables EIGRP authentication on the interface. IP authentication keychain EIGRP AS number and the keychain name specifies the name of the keychain that will be used for authentication. And based on the same information above, if a router uh, were to receive a key string as part of the authentication process, it would try to validate that key against the same key number in its own keychain. And if the received key matches the same key number, then the authentication would have been validated and the neighbor relationship would be established. All right. So EIGRP unequal cost load balancing. EIGRP can also balance traffic across multiple routes that have different metric hits, and this is called unequal cost load balancing. The degree to which EIGRP performs load balancing is controlled by the variance multiplier router configuration command. So the multiplier is a variance value between 1 and 128 used for load balancing. The default is 1, which means equal cost load balancing. So setting a variance value greater than 1 allows EIGRP to install multiple loop-free routes with unequal cost in the routing table. EIGRP will always install successor, the best routes in its routing table, and the variants allow feasible successors to, to also be installed in the routing table. All right, the maximum path is 6, by default 4. All right. So now EIGRP troubleshooting and verifying. So some of the commands to troubleshoot EIGRP is debug EIGRP neighbor. So that display event or actions related to your EIGRP neighbors. Debug EIGRP packet that displays events, actions related to EIGRP packets. To verify EIGRP, we have commands like show IP protocols that shows the parameters and current state of the active routing protocol. We have show IP root EIGRP that shows a routing table with only EIGRP entries. We can verify with show IP EIGRP traffic that shows the number and type of packets sent and received. Show keychain shows authentication key information. That is all in this video. Thank you everyone for watching this tutorial, and I would like to say a big uh, thank you again, and wish you all the best for your future roles. Goodbye, take care.